Hi everybody, this is Mrs. Valentine. We're going to give this a try and see how it goes. All right, so today is the first day of a mini lesson for both Math 7A and Math 8. You guys are at the same place right now. So Math 8, these slides should actually look familiar because we did this on the last day, I think on Thursday before we went on break. So you've actually seen this lesson. But it's been a while and a lot has happened between now and then. So I thought it would be okay to go ahead and show you this again just to kind of get you in the routine. But you don't need to take any extra notes or anything. Oh, by the way, go ahead and download the slides into Notability. And then you can just write on the slides just like I'm doing. And we can kind of work along together. Also, just sort of a note for while you're listening to a video, pause this whenever you need to. So if you want to start trying to do the problems on your own, stop and pause it, and then you just hit play again to see if it's coming out correctly for you. So yeah, anyway, just give that a try. All right, we'll figure this out as we go along. All right, so today, have a well Wednesday for both everybody in Math 7A and Math 8. You guys are getting the same assignment, and today is the 25th. So I'm going to give you two little things to do. Remember, we're not going to have another mini lesson. Actually, we're not going to have another one this week because our days are Mondays and Wednesdays. So this is the only one this week. So you're going to do two things for me. One is you're going to submit a short note summary, which is just going to be answering the essential question. And then the second thing is I'm going to make you just a real short little practice page for you to do on separate paper to practice exponents. But it's just going to be really, really short. And you'll end up taking a picture of that and submitting that on Google Classroom as well. Okay, so 8th graders, take your notebooks out. You can go ahead and look at the notes you already took for this so you can just kind of follow along. And if you lost them, well, then maybe you want to start taking some more. And 7th graders, you guys, 7A students, go ahead and just work right along with this. All right, here we go. Let's go to the next page. Oh, let's see if I know how to do this. Do I know how to do this? Yes, I do. Okay, here we go. So today we are learning about exponents. Your essential question, are these two expressions equivalent? Explain. An equivalent means, are they equal to each other? Are their values equal to each other? So you're going to be able to explain that by the end of the time with this lesson. So a little bit of vocabulary. Again, 8th graders, this should look familiar. First is exponent. And you'll notice everything is color-coded. So the bright blue exponent or power, it's the raised number telling how many times to use the base as a factor. So you see down below that you've got the exponent right here in the 3 and right here in the 4. Those are your exponents. Your base is the number being raised to a power. Let's see if I can, yes I can, look at that. So there is your base, the 5 here and the 4 here. So that's, and then a factor is any number or variable being multiplied. So in the first example, your base is 5, your exponent is 3. So that's telling you use 5 as a factor, as something being multiplied 3 different times. So here we have that being multiplied once, twice, 3 times, times itself. And then the same with x to the 4th, we're using x as a factor 1, 2, 3, 4 times. So x times x times x times x. So here's something to think about. Is 3 to the 5th power the same as 3 times 5? Why don't you pause this and see if you can figure this out? And then you can resume it in a second and I'll kind of work through it. Okay, so you're back. 3 to the 5th means 3 times 3 times 3 times 3 times 3. Whereas 3 times 5, well, that's it. That's all it is 15. If you'd work this one out, 3 times 3, that makes 9. 3 times 3, that makes 9. And we still have another 3 to bring down. So 9 times 9, that's 81. Bring down the 3. 81 times 3, that's 243, right? 243. So are they the same? Definitely not. Here you have 3 being raised to the 5th power. So it's being used as a factor 5 different times. Whereas 3 times 5 is like saying you've got 5 groups of 3. That would be like 3 plus 3 plus 3 plus 3 plus 3. That's what 3 times 5 means. Okay, so let's take a look at writing these in factored form. So that means writing them out as a multiplication problem and then working them out or evaluating them completely if we can. So 8 to the second is just going to be 8 times 8, which is 64. Again, pause in between here if you want to try them on your own. 4 to the third is 4 times 4 times 4, which means we've got 16 times 4, which comes out to 64 also. And then for this one, you can only just write this in factored form. So this would be x times x times x times x, because we've got 2 different bases here. We've got x as a base, and then we also have y as a base. So times y times y. So x is used as a factor 4 times, y is used as a factor twice. Okay, so now we're going to just try to use exponents to write these as simply as possible. We're not going to work them out. So I see 5 is being used as a factor once, twice, 3, 4, 5, 6 times. So this is 5 to the 6th power. On this one, I see 3 is being used as a factor 1, 2, 3, 4 times. So it's 3 to the 4th power. On this one, I see 6.5 is being used as a factor once, twice, 3 times. So 6.5 to the 3rd. And here I see x is being used as a factor 1, 2, 3, 4, 5 times. So it's x to the 5th power. That's it. Easy. Okay, negative signs. Negative signs can be a little tricky with exponents. To raise a negative number to a power, put it in parentheses. So here you've got negative 7 is in the parentheses and it's raised to the 2nd power. So that is equal to negative 7 times negative 7, which is equal to just 49. Over here, negative 2 is held in parentheses and that whole thing is raised to the 3rd power. So it's negative 2 times negative 2 times negative 2. So let's see, the first 2 to multiply together, that gives us 4. Bring down that one more negative 2 to multiply, and that gives us negative 8. Okay, here's the tricky part. When you do not have parentheses, it's telling you that the negative is not part of the base. So it is not raised to the power. So what this is actually telling you is give me the opposite of 7 to the 2nd power, which is 7 times 7. So this is automatically going to come out to negative. 7 times 7 makes 49. Over here, same thing. This is saying give me the opposite of 2 to the 4th power, or 2 times 2 times 2 times 2. So it's automatically going to be negative. Let's see, that's 4. That's 4. 4 times 4, so it's negative 16 that comes out to. So see the difference there? Each of these, the negative is just on its own outside, and the only thing that's being squared here is the 7. The only thing that's being squared to the 4th power here is the 2. Okay, so let's go ahead and try these. Again, I would encourage you to pause in between. I'm going to keep it going just so that you can watch this as many times as you need to and it's not too slow, but pause in between. So maybe you want to pause and try them all and then turn it back on and check. Okay, here's the first one. So that negative is not in parentheses, so the negative is out in front, and it's 5 times 5 times 5 times 5. So it's negative of 25 times 25, which I just happen to remember comes out to 625. So negative 625 is what you get for that. Whereas over here, negative 5 is in parentheses. So you have negative 5 as a factor 4 times. You get 25 times 25, which comes out to just positive 625. So there is a difference. Over here, parentheses around, we have negative 8 to the 2nd power. So we're using negative 8 as a factor twice. That comes out to positive 64. Whereas here, no negative, your base is just plain 8. The negative is out by itself. So 8 is being raised to the 2nd power. So this is going to be negative 64. And the last two, the base here is just 4. The negative is by itself. So 4 is being raised to the third power. So that's going to give us what? Negative 16 times 4, so negative 64. And then this last one, the parentheses are holding that negative on, so it's negative 4 to the third power. Negative 4 is at your base. So that's going to give us 16 times negative 4. Oops. So that's also negative 64. So you'll notice these two came out the same. Think about why that might be. Okay, so if you look above, they all had even powers. So the ones with the even powers, if they had the parentheses on them, they always came out to something positive. So that was positive. This was positive. If they did not have the parentheses on, that negative stuck around no matter what. Whereas here, you have the negative sticking around no matter what for on number 16, and on number 19, that negative just happens to be there because you had 3 negative factors. The first two with the 16 became positive. The last one was still negative, which turned the whole product negative. Okay, that's it. The first assignment you have is to use your notes to help you answer the essential question on Google Classroom. And here's that essential question once again. Are these two expressions equivalent? Explain. So if you could enter that, a couple sentences or, sentence with some examples, with the examples worked out, that would be great. And just type that right into Google Classroom. You don't need to do it separately. Just type it right into Google Classroom. And then I will also have a short little practice assignment attached as well for you to do on separate paper and then take a picture and submit. Okay, have a great day. Remember, you've got today, you've got tomorrow, and you even have Friday to work on these 2 things left to do. The summary, answering this essential question, and then the short practice. So take your time. You don't have to do it all in one day. Relax. I know you've got a lot of other things going on, so just do the best you can. Okay, bye everybody.